The structure of carvone, which is responsible for the odor of spearmint, is shown below. What is the molecular formula of carvone? So this problem is focused on making sure that we can interpret these sort of skeletal structures, which we use very often as organic chemists. So in a skeletal structure, the carbons and the hydrogens that are attached to carbon are implied. So what we need to know is at the end of any line or any point, if there is not a symbol for an element drawn, then we understand that to be a carbon. So the first thing that I'm going to do is I'm going to highlight the carbon atoms. So we see here we have a carbon. At the other end of this double bond, we see the elemental symbol for oxygen. So that means that this is a carbon double bonded to an oxygen. So we don't assume this to be a carbon because we've got a symbol here telling us what element it actually is. So every other spot here is also a carbon. Every other spot where we don't have an elemental symbol, we know that that is a carbon. So we can highlight them all. Okay, and we can see that we have 6 carbon atoms in this hexagon, and then outside of the ring system we have 1, 2, 3, 4. So we have a total of 10 carbon atoms. And we can clearly see that we have 1 oxygen. So what we need to also see is where the hydrogens are in this molecule. So we know that a neutral carbon atom forms 4 bonds. And we know that all of the atoms of this ring are neutral because we don't see any formal charges. If there were a formal charge, we would see a positive or a negative next to one of those carbons or the oxygen, but we don't see any, so they are all neutral. So what we want to do is we want to fill in the valencies of all of these carbons with hydrogen. So that means anywhere that we don't see 4 bonds to carbon, we want to make up the balance to get to 4 bonds by adding hydrogen. So starting again here at this double bond, we see 1, 2, 3, 4 bonds to carbon, so there are no hydrogens there. Moving to the next carbon, we can also see 1, 2, 3, 4 bonds. Out here at the end, that carbon, we can only see 1 bond, so that means we have 3 hydrogens there. Moving to the next carbon, we see 1, 2, 3 bonds, so we have 1 hydrogen. On the next carbon, we can see 2 bonds, so we want 2 more bonds to hydrogen to make 4 bonds total. Moving to the next carbon, we can see 1, 2, 3, so we need 1 hydrogen. On the next carbon atom, we can see 1, 2 bonds, so we need 2 hydrogens. And then finally, moving out to this portion of the molecule, we can see a carbon with 1, 2, 3, 4 bonds, so there are no hydrogens there. Moving out 1 carbon, we can see 2 bonds, so we need 2 more bonds to hydrogen. And finally, on our last carbon here, we only see 1 bond, so it needs 3 more. So there are 3 hydrogens there. And then we just need to tally these up. So we can see 3 2s, that's 5. So we've got 5, 6, 8, 10, and then 14. So this is C10, H14, and then we see the oxygen. So this is D.